Welcome to the Introduction to R video module for the Modern Tools for Data Science course. This is the video I made for the Fall 2020 offering, which just happened to be Election Day, November 3rd, 2020. So we've spent the first part of the semester focusing on Python, and we'll spend the next several weeks focusing on R. And so first and foremost, I know a lot less about R than Python. So there will be several questions, or lots of questions probably, that I don't know the answer. I'll do my best to find the answer when they arise. Also, from my personal experience in teaching this class, what I usually find is people who have programming backgrounds generally prefer Python. People who don't have programming backgrounds generally prefer R. Now, this is not a representative, or this is not a scientific sample by any way. This is just something that I've observed through teaching this class several times. Second thing I want to mention is that we'll go through the material quite a bit faster than we did with Python. So a lot of the concepts that were new when we covered them in Python, like rectangular data sets, records and attributes, slicing, filtering, aggregation and grouping, plotting, and so on, were new to the course, but they're equally applicable here in the R context. So it's the same basic concepts that we saw in Python, we'll see in R, it's just with a different language. And so that allows us to go quite a bit faster in this R section of the course. And so we're going to spend about 5-ish classes, depending on how quickly we go on the R material in the class. So what is R? Well, I pulled this definition or a description of what R is from the R project website, and I'm going to show this website here in just a little bit, and we're going to talk specifically about the organization and things like that. But what I want to focus on here is just what is R itself. Well, it's a language and an environment for statistical computing and graphics. It's also something called a GNU project, and so we're not going to spend any time talking about what this is, but I will say that this is an interesting project, and if you go to this webpage, which as I said I'll show here in just a little bit, there's a link. This is a hyperlink, GNU project hyperlink, and you should have a look at it if you're not familiar with that, but we're not going to focus on that in this class. So it's a language for statistical computing, and as I have highlighted here in orange, I'll just read this to you, provides a wide variety of statistical, and by statistical, we're saying linear and nonlinear modeling, classical statistical tests, time series, classification, clustering, etc., and graphical techniques, and is highly extensible. So from our perspective, what we're interested in is this notion of statistical capabilities, graphical techniques, and highly extensible. And this extensibility, as we will see, is what makes R a very widely used modeling tool and statistical analysis tool. So it's also historically based on a language called S, and S was developed by AT&T, so it was a proprietary language, whereas R is an open source language. And so that having the language be open source and highly extensible is what allows people and organizations to contribute and extend the usefulness of the language. So we have several R-related resources that we'll use in the class. First of all, we have our GitHub repository. So let me jump over here for just a second. You can see our repository here, and I'm going to show some of the R components here in just a second. But basically, we're using the same data directory that we did with Python. So it's all the data that we use is there. And the R code is in the code R subdirectory. So you can see that I've already populated it with some of the R scripts that we're going to use in the initial part of the class. So the GitHub repository we will use. We're going to use a tool called RStudio, and I'm going to defer this for a couple of slides because I have a lot of material on RStudio that we'll get back to. We have our R textbook, which is R for data science, and so we have that here. And as with our Python textbook, this is all available completely online, and it's available at the website here. And so we will use this book, and I'll talk more about the structure of the book and how we'll use the book here in just a second. We have the R project for statistical computing main web page that you see here. And this is what I mentioned before, where if you go to About R here, this was the language that I pulled. And there's the GNU project link that I mentioned before. So I just copied this into that previous slide. And also we can see here that we have the CRAN link. And so CRAN is the Comprehensive R Archive. And CRAN is where you can download R. And so you download from a mirror site. So let me just pick one here in the US. It doesn't really matter which one you pick. So just pick the one that I already picked previously. And these should all look the same by definition of a mirror site. And so here's where we downloaded the R. And this was done. We did this back in the beginning of the class for those of you that installed it then. And so you can see you can install the software from here, and you also have the contributed extensions, so the packages. And we said that R is highly extensible, and so if we just pick one of these, and then let's just go look for sorted by name. And then you can see that there are just lots and lots and lots and lots of packages. These were all contributed, and you can find just about any kind of statistical technique that you need. There's almost certainly someone who's contributed an R package to address that problem or to address that technique. So we will use some of these. We won't use nearly all of these. We'll just use really touching the surface of what's available. Next, we're going to look at something called Tutorials Point. This is a nice R tutorial. So I pulled some of the material that we'll see in the basic R programming from this site, which you'll see some overlap here. But I would suggest if you have no background in R, this is a really good place to go and learn and to just follow the entire tutorial through from beginning to end. It's a really nice tutorial that we have. And then finally, before we get to RStudio, I'm going to talk a little bit about something called the Book Down. And so Book Down is, in fact, itself an open source R package I'll just read this to you, facilitates writing books and long form articles and reports with R. And so you use a tool called R Markdown, which we'll see here in just a little bit. And I brought this up because if you scroll to the bottom here, you can see that our textbook, here is our textbook, R for Data Science, is written in R Markdown, and it's available on the Book Down site. There are also a couple of other ones that I will just highlight here that I use some references to, but are really excellent books for general R programming. One is Hands-on R Programming with R that you see right here. And then the other one that we will use a little bit of material from is this R Programming for Data Science. And so this Book Down site is really useful. And if you end up using R for your research or your projects, that this is a really nice tool that you can use to do reports and things like that directly from the tool itself. And so there are several of resources that I said we'd use, but there are many, many, many other tutorials online with code samples and everything. And so there's an enormous amount of material available, as we saw with Python, equally true of R. And so if, for example, you don't like the Tutorials Point tutorial, there are lots of other tutorials. And you will find tutorials that are addressed to Python programmers, to non-programmers, to people who know SAS, or people who know SPSS. And so you're going to find tools or tutorial information for any type of background that you have. So the information is out there and it's freely available. So I definitely suggest that you find something that's going to help you learn the tool. So the features of R, and so note I pulled this directly from the Tutorials Point tutorial that I mentioned previously. So I just want to talk about what makes R a tool particularly well suited for data science and for the kinds of things that we want to look at in our class. And so first of all, it's a well-developed, simple, effective programming language. So it includes things like conditionals, loops, recursive functions, I/O, so files and things like that. And so if you remember back when we talked about the pillars of programming, we talked about assignment, sequence, selection, and repetition. And so R has robust capabilities in all of those programmatic concepts. This effective data handling and storage facility basically means that we have a persistent environment. So we can save data. It's not simply a matter of reading and writing files, but we can modify the structure and things like that as we're working with the data in an interactive session, and then we can save that. And so the data is persistent, and so that's very useful. This suite of operators for calculations on arrays, much like we saw with NumPy, this offers vector-based arithmetic, which, as we saw, is significantly faster than loop-based arithmetic. Uh, Integrated collection of tools for data and analysis. Back to the extensibility, there are just lots and lots of tools available, all integrated into the environment that we'll see. We'll see some of those in this class. As I said, we're just going to see kind of the tip of the iceberg here. But I think you will agree at the end that it's highly useful. And then finally, graphical facilities for data analysis. So as we saw with Matplotlib in Python, we're going to see equal capabilities in R, and we're going to look at a single package, but we will also mention several other R packages that support high quality graphics for both computer visualization and for publication, printing in papers. So the outline for the coverage that we will do from R for Data Science, which is our R textbook, I have listed here. And so one thing I'll mention about the book is that, as we saw with our Python book, this is not a programming book. So this is not a book that describes programming with R. It describes applying R in a data science context. And it provides some background, a little bit of background on programming, but we're going to supplement that in our class. So the first thing that we're going to do is we're going to talk about RStudio. They talk about that a little bit in chapter 1, and then there's some RStudio related websites we're going to take a look at. We're going to do that here in just a second. And then we'll offer a brief introduction to R. And so there's a little bit of material in the book on chapter 1, but this is where we're going to draw from the tutorial point, miscellaneous other material, and then some from chapters 14, 15, 16, 19, and 20 of the book, where we go into some of the more advanced features. But we're going to just do this kind of at a high level informational perspective. We'll then jump into data visualization, which is chapter 2 of the textbook, data transformation, chapter 5, something called exploratory data analysis, which is chapter 7. So this is primarily visualization in chapters 3, 4, and 5. The transformation does some aggregation and grouping, like we saw, and some other transformational type functions. We're going to cover something called a tibble in chapter 10, and then data importing, something called tidy data, which we've seen before, but we will go back and detail it a little bit more. And then finally, relational data in chapter 13. And so this is the material that we're going to cover from the R for Data Science textbook. As I said, we're going to have 5-ish classes on this, so some of this coverage might be modified a little bit as we go and just kind of see how we progress through the material. But this is the basic outline that we're planning to do. So the last thing that I'm going to cover in this introductory video is RStudio. And so there's a lot of information about RStudio, and I've got several different websites linked here. But rather than just talk about it from the PowerPoint, let's just go to the website and talk a little bit about what RStudio is. So RStudio is several different things at once. Primarily, when people think about RStudio, is what they think about when you go to the product, is they think about this IDE, or integrated development environment for R. And so that's the tool. So when we talk about using RStudio, that's what we're going to use. And RStudio is the development environment that we're going to use throughout this class. And so we'll see that here in just a second. RStudio supports something called projects, which we will see we'll actually use in this class. But three other things before we get to that is something that I just wanted to mention that we'll see used. First is R Markdown. And so R Markdown lets us have a notebook interface, as we saw with Jupyter Notebook, and it lets us include text and graphics and executing code all within a single document. And so this R Markdown is the basis for the Bookdown package that I showed just a second ago, where people write textbooks and long form papers and things like that using Markdown. And so we'll see that here in the course. Also note that the notebook interface supports multiple languages. So you can have R and Python and SQL all within the same notebook, which we'll see just a little bit. There's also another link for our notebooks themselves, and this talks more about the notebook interface and so on. So we'll see this. We'll see a couple of examples of this and have a homework probably where you submit an R notebook as the submission for the homework. And so the last thing I'll mention here, and this is really for your information, is another component of a common or major component of RStudio is a package called Shiny. And what Shiny does is technology that lets you build interactive websites directly from R. So you don't have to know anything about web development, back-end processing, and you can use this tool to develop interactive websites. And so there's an example here. Here's an example. I guess I don't have this. I guess I am disconnected from the server here. So let me reload here. And so you can see that this is an interactive website that was built using Shiny. And here's the app. So here you include the app, and this is just all R code. So you're not doing any direct web development. All the web development comes indirectly through the use of this of the Shiny package. And so from the context of RStudio, again, it's the IDE is what people mostly think about, but you also have this fundamental idea, the fundamental packages of R Markdown, R notebooks, and as I mentioned, Shiny. So we'll talk about the basics of R programming in the second video in this module, but what I wanted to do is just sort of demonstrate RStudio here. And so you can see I have the application open, and you can see I have several different panels here. I have a console, I have something called the global environment here with some other options, which we will see all these options here in just a little bit. And then down here we also have a file window. We can see plots, we can see packages. So we talked about our packages. So we have an interface that lets us, that gives us access to those. We have the help window, and then we have something called the viewer. And again, we will see that here in just a little bit. And so when you open RStudio, this is the basic default environment. And I mentioned one of the things that it's supported in R is the notion of projects. And so for our class, we're going to use a project, or I'm going to use a project. You can or not, as you will see here in just a second, as your choice. But I have a project that's defined with the class. So I can go to Open Project, and then I can just navigate to the GitHub. And when I go to, there's my GitHub, there's tools for, and here's the R project. And so note when you get the repository, you won't see this. So I have this file particularly excluded from the GitHub repository, so you don't see it. But if you want to follow my structure, you can just create one. So you can just create an RStudio project in the same location, and you will see things exactly as I do. And you'll see why this becomes important here as we go forward. So if I just open that project, you can see now I have a project here listed at top. It remembers where I was before when I saved it, and so I happen to have the basic R programming script open. So I clicked on this and it opened the script, and it maintains this global environment. And so you can choose to have this, to have the project in the same structure, but where that becomes important, as we will see, is when we get the working directory. So when you remember when we did Python, we had, working directory. It's important to know where the working directory is, because as we open files, we need to include the file path. So we'll see that. And so if you were to create your own project in the root directory of the GitHub that you downloaded from the repository, then you won't have to adjust any of the file paths when you use my code. Otherwise you will, but that's pretty straightforward to do. So we look, and we're going to go through what this R code does here in just a second, but I just want to do one quick thing here as we talk about RStudio. So I'm going to execute this one line of code, and what this one line of code does is it assigns the value, the string value, hello world, to a variable called myString. And if you look over here on the right under something called the global environment, you can see when I executed that line of code, it actually stored that value. So this is similar to what we saw in the Spider IDE with Python, in that we have a global environment where we have the namespace and the objects and so on. So that's very similar to what we saw. But when we talked about a persistent environment, so I just want to show how this works. So here I am, I opened the project, I then executed some code that created an object in the environment. And so now when I exit, it's going to ask me, do you want to save the workspace? And if you say yes, it's going to save it in something called .rdata. So let's do that. So I save that, and then I can look in File Explorer, and here is the directory, the GitHub directory, Tools for Data Analytics and Modeling, and you can see here was the R project, and now here is that R data, which is the persistent state of the data. So now I go back, and if I reopen R Studio, you can see my global environment persisted, right? And so it saved the environment in that file called .rdata. Now, when you download the repository from GitHub, you don't see that file either, because I also have that excluded, because that file can get large, and that and the project really kind of depend on what you're doing with R when you save it. So that's not something that I want to have in the repository. That's something that you want to store locally so that it maintains the persistent state of where you happen to be working with R. Okay, so RStudio, I would encourage you to look through the user guide a little bit that is on the website and just sort of get familiar with the interface. And in the next video in this module, we'll start going through this particular script where we talk about basic R programming.